I'm going to start my today's session with further discussion on continuous probability distribution. And yesterday, as you know, that I discussed this chapter with CSE section B. And for the sake of your preparation, I also uploaded the video in the YouTube so that you can have some idea, some sort of idea from my previous discussion on the normal distribution or normal random variable. And those who have seen my videos, they have probably seen also that the presentation which I am showing right in front of you right now at this moment, the same presentation was actually presented yesterday with CSE section A students. But still today I'm showing you the same presentation because some of the portions of that particular, this particular note was left to be discussed, and therefore I'm going to continue from that part. So I hope that as I am scrolling down, you can see the pictures and the expressions and the problems and the table. All these things are actually important, and they have been discussed with sort of mathematics which I did to explain the things. Now I want to discuss the problem I did up to this. Okay, now I'm going to discuss this problem, question number 1, because the problem later I thought that it needs to be discussed because it is very important. Now, let us first read the problem. Suppose the amount of time of a light bulb works before burning out is a normal random variable with mean 400 hours and standard deviation 40 hours. If an individual purchases 2 such bulbs, one of which will be used as a spare to replace the other, when it burns out, what is the probability that the total life of the bulbs will exceed 750 hours? Now, when I will suggest you that when you will look at a problem, just look at the problem not for the sake of solving the problem. Look at the problem and try to feel the practicality of the problem. And then you try to identify the information which is given in the inside the problem, inside the question. And then you try to do it with your available tools. Now, I know that if I ask you this question, and if you have gone through my video, some of you will be able to do the problem by yourself. But what I need to discuss over here is that this line, which is written over here, that suppose the amount of time of a light bulb works before burning out is normal random variable. Now, in this question, they are saying that this amount of time a light bulb works before burning out is a normal variable. How do they know this? They know it from their practical experience. They have studied market. They have gone through several bulbs manufactured by different factories. They have gone through several tests on the manufactured bulbs. And from the previous record or from the previous data, they know that the light bulbs actually behave in this fashion. Okay. So when the consumers buy the light bulbs, they burn the light bulb for certain range of years, from x1 years to x2 years. Within this range, the light bulb intensity reaches its maximum at this point, and after that it decreases, and then one day a year comes when one day of that year it just dies. Okay, so they have given you this information from their experiences taken from different sources, and they have shown that in most of the situations the light bulbs are behaving like this. The longevity of the light bulb, or amount of time a light bulb works, this is called the longevity. That is actually a normal random variable. Now, once this information is given, then immediately we have to identify if this is the normal random variable, then let us name this variable. Okay, so we have named the variable to be capital X. Okay, now what is given? It is given that what am I supposed to find out? What is the probability that the total life of the bulbs will exceed 750 hours? Now, that is the thing which is very important in this particular case, because we are actually not interested about the longevity of a certain bulb. Okay, we are actually interested in the longevity of, just a minute, of the total life of two bulbs considered. Now you see that do not look at the sentences which I have written in the solution portion. First, you try to understand, just look at the question. It is given that if we have a light bulb, its amount of light bulb, its random variable, say we are considering the random variable to be capital T. Suppose T is the amount of time the light bulb works. Suppose then in this type of situations, it is known that expectation of capital T is equal to 400, and variance of not variance, it is given standard deviation. Standard deviation capital T is equal to 40. It is given from these particular sentences. Okay, now we know the mean and standard deviation of the longevity of the light bulbs. This is a known fact. Now, what is given? If an individual purchases two such bulbs, one of which will be used as a spare to replace the other when it burns out. Now, when it is given that the individual purchases two such bulbs, each of these bulbs will have some longevities. Suppose the longevity of the light bulb 1 is capital X and longevity of the light bulb 2 is capital Y. When X will burn out, then Y will replace X, or Y will take its position. Now, both of these random variables, capital X and capital Y, they represent the same thing, the amount of time the light bulb actually burns. We are supposed to find what is the probability that total life of the bulb will exceed 750 hours. Now, if one variable is capital X and the other variable is capital Y, then X plus Y is the amount of time that the total the light bulbs together burn, or the total lifetime of the two bulbs taken together. Now we are going to find out what is the probability that this total amount of the two light bulbs exceed 750. Equality symbol will not be there because they are asking us to find the probability of strictly greater than situation. Okay, now you see that when I supposed that there are two variables, capital X and capital Y, for two different light bulbs, and we know that light bulbs behave, the amount of time the light bulb works behave in the following fashion. So this Ex equal to 400 and standard deviation of X, which is 40, it's not only happening for the first light bulb, it happens for the second light bulb also. So both of these light bulbs will have the same amount of mean and the variance or standard deviation. Okay, understood? Now, at this point, you know that you have, if you have seen my video, that here my normal variable to be considered is capital X plus Y. And if I want to find out this probability, then what will I write? Immediately after that, I need to bring standard normal variable on the left hand side, that is capital Z. As I told you in the last class, told the students in the last class, that the solution of the problems become easier if you try to look at the problem from the perspective of standard normal variable, because in that situation the axis comes to the middle. Okay, in this situation the axis comes to the middle, and therefore we need to bring Z on the left hand side. And to do this, as you know, the standard normal variable is denoted by x minus mu by sigma, but here my capital X is x plus y. Then I need to find what is E of x plus y and what is standard deviation of x plus y. Actually, I need to divide, need to subtract E of x plus y from both sides, and we have to divide both the sides by standard deviation of x plus y. Okay, so let us write the inequality. So we need to get this, and if I do so, then on the left Z will come by the formula, and on the right something will come. The question is, what is that something? Because left hand side by expression it is capital Z, but obviously the right hand side is not an expression. It has to be, this right hand side has to be a number, a numerical value. So we need to know this, and for this we actually need to know what is E of x plus y and what is standard deviation of x plus y. So therefore, in the next page you'll find that I have given a theorem over here. This theorem is called, let me erase the unnecessary portions so that you can read it well. This theorem, just read it out. This theorem is called additive property of the normal random variable. What does it say? This additive property says that suppose capital X and capital Y be two independent normal random variables with means mu and eta. This expression is called eta, it's a Greek letter, and standard deviations are sigma and tau. It is not capital T. I'm writing it properly. Okay, just a minute. So it is given in this particular property that expectation of capital X is, if expectation of capital X is mu and expectation of capital Y is eta, standard deviation of capital X is sigma and standard deviation of capital Y is tau, then in this case the x plus y, their total is also a normal random variable where expectation of x plus y will be equal to mu plus eta and standard deviation of x plus y will be equal to sigma square plus tau square under square root sign. Or you can say the variance of x plus y is equal to sigma square plus tau square. This is a well-known property. It is called the additive property. Now we have our expectation of capital X and expectation of standard deviation of capital Y. It is already written over here. So we have got our formula. So in this particular scenario, you can see that we have got that here I am going to write 750 and 400 plus 400 by under square root sign 40 squared plus 40 squared. Okay, now rest of the calculations is written, is printed, so I don't want to write it anymore. So you see, by applying the above additive property, we have got the expectation of capital X plus Y and standard deviation of capital X plus Y. So once these values are known, then you can find the probability in the following manner. So what have I done? Let us see that after the calculation, the left hand side is becoming capital Z and the right hand side is becoming minus 0.8838. Now your job is to calculate this probability. If you carefully observed my yesterday's video in YouTube, you have probably seen that I told you each time you do the calculation, on finding the probability with respect to standard normal variable, it is a good practice to write. It is a good practice to draw the figure so that the origin is always in front of you. If I give you 10 problems on normal random variable, I always ask student to draw 10 figures for each of these 10 problems. It is a very good practice. Actually, students, I have seen from my personal experience while checking the copies, the students often miss this point. They do not listen to the teacher. So each time you do a normal random variable problem, try to draw the figure as I have drawn it. I have pasted the figure. The figure is stretching from minus infinity to plus infinity. It's a symmetric curve. It is a bell-shaped curve. This is the midpoint. Mean, median, and mode of the distribution coincide at the single point, that is z equal to 0. The left-hand portion is the negative side. Right-hand portion is the positive side. Horizontal axis is the asymptote to the normal curve. Asymptote are such entities which are actually tangents touching the curve at infinity. So here the horizontal axis will touch the curve either at plus infinity or at minus infinity. And left hand side will contain 50% of the total area, right hand side will contain the 50% of the total area. These are the properties which I discussed in the last class. Now, what am I supposed to find? I am supposed to find the probability that z greater than minus 0.8838. So I have marked the point minus 0.88 on the left hand side and at equal distance a point 88 on the right hand side. Okay, although my diagram, the marking is not actually very good, it has to be appropriate. Now you see that, okay, according to this particular thing which I have obtained, we are actually supposed to find the area of this region, z greater than minus 0.88. So we are actually interested in finding area of this portion. So I am marking the portion for your understanding. If you are noting down the things in your copy, you also mark it with a particular color. It would be always nice if you can use different colors other than red in the examination. So we are interested in this particular area. Okay, we are interested in this particular area. Now, since you see, since this normal curve is symmetric, curve, so the area falling on the right hand side of minus 0.88 will exactly be equal to the area falling to the left hand side of the point 0.88. So I'm marking this as well. Just look at it, what I'm doing. I'm marking these areas properly. So these brown colored portions, the area of this brown colored region will be exactly equal to the area of the yellow colored region. Those two areas will be exactly equal. Okay, and we have calculated the thing which is the problem. The probability is coming out to be 0.81. Now, how we have got the probability to be 0.81? Since you are doing it for the first time, I'm going to show it. Show the calculation to you. so that you understand the thing properly. Okay. So I'm going to erase this particular region which I have marked, because if I scroll up and down, this particular markings will be carried forward. So you have understood that these two areas are same because the curve is normal. Okay, but the point is how to find this particular probability. Just a minute. Okay. So next I'm going to show you how to calculate the probability. So probability of capital Z less than 0.88. Okay. Now this probability can be found. Now look at this figure once again. This is my point. Okay. Now I can find the probability of this area if I can break the, it can be found in various ways. One of the ways is if I can write it as area lying under -infinity and 0 plus area lying between 0 and 0.88. So if I can find the area of this portion, and if I can add the area to this, if I know the area of this, then the addition of the two things can give you the area of the required region. But I think that according to the note given, which I have given you, we shall not be required to find the probability of each of these regions. Why? Because see, this area where Z lying between -infinity and 0, it is 0.5 because it contains the 50% of the total area. I only want to know this one. But why am I saying that this will not be required? Because the chart which I'm following presently, in this chart itself, you see, carefully you observe, and yesterday also I told that various charts they follow. This chart is actually meant for probability of Z less than small x. What does that mean? They are actually giving you the area of the region from -infinity to a certain point. They have calculated all the probabilities in the chart. In this particular case, the book from which I have pasted the chart, I have copied the chart, they are actually giving, has provided the area of this type of regions. But I am interested in finding the area of this probability of Z less than 0.8, isn't it? And this is nothing but area lying between -infinity and 0.88. Okay. Now what you are supposed to do is that try to identify the row heading, that is 0.8. First of all, try to identify the row heading from the table. Now here you see now here you see 0.8 is there, and I want 0.88. So I have to go to the last but one column, that is this one. And if I go like this along this horizontal line, and if I go like this along this vertical line, the probability at which they cut each other is this one, which is 0.8106. 0.8106. So this table has directly come, this particular value actually has come from directly from the table given. Now, if anybody asks me that I don't want to use the probability table, I want to calculate the probability, how can I do so? Yesterday I have explained. Then in that particular situation, you have to integrate the function this from -infinity to 0.8 with the help of numerical integration processes. Anyways, why should I do this when the table is available? So thus we have obtained 0.81 as the required probability. Okay, I hope you have understood. Now let us scroll down and let's see what else we can find with respect to this particular normal random variable. So in this problem, I have discussed this particular problem because it is not just a problem. It is a problem where a particular property has been used, which is called the additive property. Okay. So actually that thing was actually my point of discussion for which I started discussing it. It's very important. Now another problem which I'm trying to explain. I'll move fast, a little bit faster, because you have already got the hint of what to do and how to do. I'm just reading it out. Data from the US Department of Agriculture indicate that the annual amount of apples eaten by randomly chosen women is normally distributed with a mean of 19.9 pounds and standard deviation of 3.2 pounds. While the amount eaten by a randomly chosen man is normally distributed, just a minute, is normally distributed with a mean of 20.7 pounds and standard deviation of 3.4 pounds. Suppose a man and a woman are randomly chosen. What is the probability that the woman ate greater amount of apples than man? Now, don't laugh at the problem, because here the problem is actually considering the apple eating situation between men and women. None of the situations in probability theory are actually laughable, in the sense that they always are connected directly to a practical situation. Suppose we are actually supposed to find the probability that the woman ate a greater amount of apples than a man. Suppose we are interested in finding the cure of a certain disease where it has been observed that the quality, the ingredients which is present inside the apple is uh, uh, can cure your disease. Suppose, forget about apple, suppose any fruit, we can consider any fruit. So a particular ingredient is there inside the fruit which can cure you. Now the disease has attacked people, the disease has attacked mass of people, and we've been observing since a couple of years that when the males are getting affected by the disease, their recovery time is much more higher than the women when they are attacked by the particular disease. And many more researches were conducted, and after that, suppose the scientists have come to the conclusion that yeah, some ingredients have been found inside the woman which is absent inside the man, and for that ingredient is actually, the ingredients have been found in the bloodstream of women, and that ingredient is actually responsible for the cure, rapid cure of the woman from the disease. Now when they started studying this ingredient, they have found that the ingredient is actually present inside the particular fruit, here in this case the apple. Now that means what? Most this ingredient, suppose, can only be found in the fruit itself and in no other places. That means what? Say the actually women eat more, the set of the collection of women which have been taken under consideration, they are actually apple eaters. More apple they eat than their male counterparts. So from this particular scenario, the situation has been derived, and therefore this data has been presented to you, and therefore they have said that this amount of apples eaten by a randomly chosen woman is normally distributed. Okay, it's normally amount of apples eaten is normally distributed. What do we mean by this? I am not interested in discussing the problem, because I know that you can do the problem by yourself. But here I'm going to explain the physical scenario from which the thing has been derived. The amount of apple eaten by randomly chosen women is normally distributed mean that there is a season throughout the year, the area women where the disease, the area in which the disease attacked, the women of that area, this they each apple throughout the year. Apple is can be found throughout the year in that region, and during a particular season, their habit of eating apple actually takes its peak, and then it gets decreased. You can think of Jammu and Kashmir. I cannot tell about the season in which the apples are mostly found in abundance in Jammu and Kashmir, but that can be found throughout the year. Now, their eating habits have been graphed here. This is their eating habits, and you can plot on the horizontal axis various seasons, the different points of the seasons or different ranges of the seasons. Okay, years or months or weeks, whatever. So that is the meaning of this particular sentence. Often we do not understand the meaning. What we think that, yeah, amount of apple eaten is normally distributed. What does it mean? And suppose some of you may think that, okay, why am I so be bothered about apple eating? It's a funny problem. But no, it is not a funny problem. If you can connect the problem with a physical situation, it is never a funny problem. Okay. And what else is given? Okay, let us try to find out. And since we have got our random variable, it has got its mean 19.9 and standard deviation 3.2. Amount eaten by randomly chosen man. So we have to consider two random variables here, capital X and capital Y, just like before. And expectation of capital X, if I say that capital X, the random variable responsible for man, and capital Y is the random variable responsible for women, then expectation of capital X will be 20.7 and SD of capital X will be 3.4. Expectation of capital Y will be 19.9 and standard deviation of capital Y will be 3.2. So you have to be careful which variable, you have to be careful and you have to make sure which variable is connecting to what value. Okay. We are supposed to find the probability. What's the probability that a woman ate a greater amount of apples than man? So obviously, according to the problem, we are interested in finding the probability that Y is greater than capital X. And we can express it as probability of X minus Y less than 0. Now, once you got this situation, then rest you have to do a little bit of mathematics over here. So we have got our, we know that I have already explained that what is expectation of X and expectation of Y and standard deviation of X and standard deviation of Y. So in this case, you can easily calculate your expectation of X minus Y, and expectation of X minus Y, as you know from the property of expectation, it is expectation of X minus expectation of Y, which is 0.8. And standard deviation of X minus Y is this. Why? Because try to recall that variance of X minus Y actually is given by the formula variance of X plus variance of Y plus twice covariance of XY. But when X and Y are independent, then covariance of XY is equal to, oh, sorry, one mistake. This will be minus, okay, variance of X plus variance of Y minus 2 covariance XY. When X and Y are independent, covariance of XY will be 0. And in that case, variance of X minus Y is equal to variance of X plus variance of Y. That was there in one of my notes, earlier notes, which I posted in the Google Classroom. Probably you have gone through. And standard deviation of X minus Y will be actually equal to the positive square root of variance of X minus Y. So therefore, So therefore, it is written like this. Now, standard deviation of x minus y will be root over variance of x plus variance of y. But you are not given in the problem the variance. You are given in the problem the standard deviation, which is 3.4 and 3.2. And therefore, they have been squared. 3.4 squared and 3.2 squared. Probably you are thinking, from where do this square come? So I have explained this situation, and therefore they have calculated this thing. Why they have calculated this thing? Because we have in our hand this equation, this inequation, probability of x minus y less than 0. But we cannot solve it until we bring a standard normal variable into the picture. So we can do it if I subtract from both sides the expectation of the variable under consideration, and we can divide by the standard deviation of the variable under consideration. Okay, now this variable x minus y minus expectation of x minus y by standard deviation of x minus y, that has been named as capital W. That is your capital W. And expectation of x minus y has been obtained as minus 0.8, and variance of a standard deviation of x minus y has been calculated as 4.669. And ultimately, they have got a curve. They have got an equation in terms of the standard normal variable z. And do not forget to draw the normal curve, because I'm repeatedly saying that for each of the problems, you have to draw the normal curves again and again. Okay, here I'm interested about the point that is 0.17. So I have plotted the points on the left of it and on the right of it. And then after a little bit of mathematical calculations, we have ultimately found that the probability of the required region has come out to be 0.4325. Okay, so that is how we actually try to solve different situations corresponding to different problems corresponding to different situations. My objective, my ultimate conclusion regarding this type of problems to you, that try to understand the physical system from which the problems can be derived. This the thing which I have discussed over here about apple eating things, I do not, nobody said to me this, and in the book it was not written. Since the problem is there, I know, at least I know that the problem has come from a physical situation. Try to think about that physical situation from which this type of problems can come. So it will be a good practice, and it will develop your mind. You can think of statistical problems. My time has almost over. We are going to meet after this session ends. So here I'm going to end my first session